Question number 5 deals with the spectra, A part. What type of spectra? Emission spectra and absorption spectra. B part deals with what? Yes, spectra of hydrogen. First part, emission spectra. If you take vapors at low pressure, any material, say sodium, pass electric discharge through the same. It emits certain specific wavelengths, say lambda 1 and lambda 2. It is unique for every material. Every material in the periodic table gives specific spectra. For example, sodium gives 589698. So the color is yellow. By having a look at the color, you can judge it is which material. That means every material in the periodic table will emit certain wavelengths. So emission spectra is what? Certain wavelengths are emitted. Certain wavelengths are emitted by element in gases from low pressure, say lambda 1 and lambda 2. It is what? Fingerprint. Fingerprint of a element. It is different. Spectra is, every element will have a different spectra. It is a property. Sodium emits 5896, 5898, approximately in this range. Color is yellow. Time with you is 2 minutes to write emission spectra. Absorption spectra. Now, if you take the same material and pass what type of wavelength? Yes, all wavelengths. This also, all wavelengths. This is lambda 1, this is lambda 2, other wavelengths also. All wavelengths. If a light has all wavelengths, what do you call this as? Continuous. Sunlight has all wavelengths. It is continuous. So if you pass number of wavelengths through the same material, suppose it is material X, it is also material X. Observation is that these two specific wavelengths, lambda 1 and lambda 2, will get absorbed. And what you get at the output is, this wavelength is available, this is missing, lambda 1 is missing, this is available, this lambda 2 is missing, this is available, this is available, this is available, this is available. All wavelengths are available except lambda 1 and lambda 2. Why? Because this material X has absorbed these wavelengths. Why it has absorbed? Good absorber is a good emitter also. So a material which emits particular wavelength, when allowed to absorb, will absorb same wavelengths. So what is absorption spectra? Certain wavelengths are absorbed by material. Here material is X. Such a spectra is termed as emission spectra. Sorry, absorption spectra. Example, Sun. All wavelengths are available from Sun. But when you observe on Earth, observation is on Earth you get one wavelength, second is not there, third is there, fourth is there. 3, 4. This is second wavelength is missing. When you get light from Sun, observation is all wavelengths except few wavelengths are missing. What does it mean? Material surrounding the Sun is a good absorber of wavelength number 2. So in the lab we study this material should be good emitter of a wavelength. So without taking a sample from Sun or surrounding the Sun, without moving any instrument near to the Sun, which is very, very difficult, we can judge that material surrounding the Sun is a material which is a good emitter and good absorber of a wavelength number 2. So you can identify the material in the lab without moving to Sun or without taking a sample nearby Sun. This is an example of or application of a spectra. Time with you is 3 minutes to write. Hydrogen spectra. It was also observed before Bohr could come out with the explanation. The first series is what? Yes. Yes. Lyman series. First one is this. Yes. So, atom. This explanation was given after 1913 Bohr. First orbit 1, second orbit, third orbit, fourth orbit, and up to infinity. If the jump is from, yes, 2, if the jump is to level 1, it can be second to 1, it can be third to 1 first, it can be fourth to first. So second to first, third to first, or fourth to first, similarly up to infinity. What was the formula? 1 by lambda is equal to constant, Rydberg constant for this particular case, hydrogen. 1 by n1 square, n is equal to what? 1 minus 1 by n2 square. When you put n is equal to 1 here, the series is Lyman series. What is the value of R? Approximately 10 raised to the power 7. Exact value is given? 1 point? Yes. The order is 10 raised to the power 7. So that means by having this value, you can put n is equal to 2. If the electron jumps from second to the first, this energy difference will be minimum. As energy is equal to h nu is equal to hc by lambda. This energy difference is minimum, so frequency is minimum, lambda will be maximum. So second to first lambda will be maximum, third to first lambda will decrease, fourth to first lambda will further decrease, and frequency will keep on increasing. If you find this, If you put n is equal to 2, find lambda. Put n is equal to 3, find lambda. Then it falls in range, yes. Wavelength is of what type? Yes. In the spectra. This is electromagnetic wave spectrum. This is VIB-Gayor, visible light. Before violet it is ultraviolet. Lambda falls in, yes, ultraviolet range. Time with you is 2 minutes to write. 2 minutes to write Lyman series. Second one is what? Yes, Balmer series. Here the jumps are, yes, to which level? Yes, second level. That is, jump is from third to second, from fourth to second, from say fifth to second. Jumps are to second level, second orbit. So it is this value. If you put n2 is equal to 3, then 4, 5, then you find lambda. Lambda falls in, yes, visible. That is in this part. That is why this was the first series to be observed in lab, because it can be seen by naked eye also. It falls in visible spectrum. Time with you is 2 minutes to write. Draw the diagram where jumps are to second level. Third one is Paschen series. Here the jumps are to what level? Third level. If the jumps are to third level means what? From 4 to 3, 5 to 3, 6 to 3. So jumps are from fourth to third, fifth to third. So the energy gap is less. Frequency is less. Wavelength is more. Lambda falls in. Yes. Yes. Lambda falls in infrared range. After red, along this line, wavelength increases. VIB-Gayor 4000 angstrom violet, 7000 angstrom red. So this is what? Infrared. You also term this as a thermal radiations. So lambda falls in infrared. Time with you is 2 minutes to write. Next series is what? Fourth one. Yes. Fourth series is what? Bracket. Jump is to, yes, fourth level. First, second, third, fourth, fifth, sixth. Yes, jump is to fourth level. Fifth to fourth, sixth to fourth, seven to fourth. Range is what? Yes, it also falls infrared range. Draw the diagram, 2 minutes. Fifth is what? Yes, refund series. Jump is to, yes. Which level? Fifth. Jump is to fifth orbit. Sixth to fifth, seven to fifth, 8 to fifth, up to infinity. So what we put here is, jump is to what level? Fifth. This is, range is far infrared, end of infrared. This is where wavelength lies. So we need to find out the value of the wavelength, then you can come out with whether it falls in the far infrared, micro or radio or what part. So you can say it is far infrared, that means end part of a infrared. 2 minutes with you to write. P fund series, jump is to fifth level. Formula is 1 by lambda is equal to r 1 by 5 square minus 1 by n2 square.